Hello, Bobcats. Here's another example of a standard enthalpy of formation problem. Um, Hopefully you found that appendix in the back of the book. For those of you that do not have a book, you can find them online. Here is some copied places in the book that I've gotten here. My scanner didn't come out as perfect as I would have liked, but it's legible. And I'll put up the whole thing here and also download this. See if I can get a little better copy and download it onto. But here you can see the appendix 4, selected thermodynamic data. And if you look online, they're all pretty close. They sometimes go to different decimals, but they're pretty close. It's in order of one of the elements. So you sometimes have to, if there's multiple elements, you have to check and it's by alphabetical. You have to check the element. There's the first page: aluminum, barium. There's a couple columns here. The first one is the standard formation of enthalpy, kilojoules per mole. The next one is Gibbs free energy. Next one is entropy. Right? It'd be interesting to get into some of that. This is some deep thermodynamics. But this enthalpy here is really some thermochemistry. So you can see them all here. Some on the next page. I'll put them up so you can see at least all of them, and you can go through and pause the video if you need. But let's come to this example here. This is nitrogen dioxide gas and water producing nitrogen trioxide and nitrogen monoxide. Notice this should be HNO3 here. There's a mistake here. Type that in here. This should be nitric acid, aqueous, notice, and nitrogen monoxide gas. Yes. Okay. So we check our chart here. You can find, look up first nitrogen dioxide. Notice there's 3 moles, so this example has different moles in it. And if we go to it's in alphabetical order here, go to the nitrogen portion. You can find there is nitrogen monoxide, nitrogen dioxide gas, and it has a standard enthalpy of formation of 34 kilojoules per mole. Sure, everyone sees that there. It has, nitrogen dioxide gas, 34 kilojoules. I'll add that here, 34 kilojoules. Water in the state of matter of liquid. So come over here to the hydrogen, which should come before nitrogen, right? It is over here. Here we have hydrogen gas. Notice the elements, I mentioned this before, the elemental enthalpy, standard enthalpy of formation is 0 for all the elements. This is our baseline. This is where we kind of our starting point so we can get these measurements. For water, you have liquid and gas here. And so for liquid would be negative 286 kilojoules per mole. Negative 286. And then, so those are our reactants. Now we look at our products here for the nitric acid. Be in our nitrogen page here. Here we have HNO3 aqueous, negative 207. kilojoules per mole. And for our nitrogen monoxide, so we have to turn to that one page. Gas form has 90 kilojoules per mole. Okay, so now our, of course, our equation, which was here, gave you yesterday. That's pretty scary there, but you can see it's the products. Okay, so now we have two products, and they both have, or one of them has moles. So what we have to do is we have to distribute this molar. So we'll multiply these by 3. Okay, we're going to add this side together. Okay, multiply that by 2, the molar, 1 mole. Okay, we'll add this side together. So what I want you to notice, though, that this is the sum of all the products. Okay, so that was going to be all of these. We'll go here. So if I pull out my trusty calculator and put this in here, we have 2 times negative 2. Oops. Let's see here. Start that over. 207 negative. Yeah, should be 414 plus 90. Maybe you can do this in your head. That'd be 324. So that's going to be my products here. So the sum of, here's the sum of the moles times the change in enthalpy of the products. So we have a 3 here and a 1 here. So we're just going to multiply that by 1. And that gives us negative 324. And then from that we'll subtract out the reactants, the sum of all the reactants. 2 times 20, whoops, that's not the reactants. Try that again. Excuse me. Should be 3 times 34. That was positive, right? Yes. Which gives us 102 plus 286 negative equals 184. So minus 184. Just to make sure we get this right here. So we have 324 minus 184 negative equals that is not the answer. Let's clear this all out. Try this again. Sorry. 324 negative minus 184 negative equals. There we go. So your answer to this, the for this reaction, the amount of energy that is given off would be negative 140 kilojoules. Pretty complicated, but math is at least simple. So try those problems I assigned. Let me know if you have any problems. And hope you have a wonderful day. Mr. Grange, signing out.